Good evening, everyone, and welcome to the Adafruit Show and Tell. I'm Liz. I'm going to be your host this evening. If you would like to join the stream to show off your projects, you can find a link to the StreamYard in the live broadcast chat on our Discord, and that's available at adafruit.it/Discord. We're going to kick things off with some folks from Adafruit, and then we'll hear some from people in the community. So first, let's hear from Scott. Hey Scott, how's it going?
Good. Thanks for hosting and having me.
Of course. Thanks for coming on.
So I've signed up for a big project.
Yes.
As you know, and that big project is implementing or adding Matter support to CircuitPython.
Yes.
And I think you have a question about that.
Yes, I had discussed this before we went live, so you had a little bit of a heads up. I had decided ahead of time that I was going to ask you a mildly mean question. What is Matter?
What is Matter? That's a good question. It's a hopefully universal standard for IoT devices in your house.
Okay.
In particular, it's supported by Google and Apple, which are interesting. So like new HomePod minis are Matter controllers, meaning that if a device so I have this like NeoPixel strip here, and it is a Matter device. And so there's a standard process to get that connected up to my Apple Home.
Okay.
You may have seen, I'll show you my QR code. So they often come with these QR codes and numbers that you can type into the app to get them all hooked up. They call it commissioning. But there's a bunch of rudimentary sorts of devices like motion sensors and temperature sensors and RGB lights that kind of like are standard protocols for this to speak. So I'm interested in adding support within CircuitPython for that. And most of that will actually be in Python land, I think, which will mean that it should be very portable to CPython as well. So
excellent.
I'm going to just show my screen. I'll show what I'm doing.
Of course, yeah.
So this is the very first packet. So after it discovers you on the network that you want to get commissioned, this is the very first packet that like my HomePod is sending to me.
Okay.
And these are all my debug prints about like what is involved or what is in that packet. So I'm down at the bottom levels, starting to parse packets, and then we'll build the higher level stuff on that. There's a bunch of cryptography about making sure the device is legitimate and that when you communicate with the device, it's all encrypted. So once I'm parsing packets, I'm going to be in cryptography land and build from there.
Very cool. I'm really excited to play with this, and thank you for taking on this project. I know it's going to be big, but I think it'll be really exciting.
We'll see. Yeah, I mean, the ideal is interoperability. It's still quite early days for Matter, but seems like people are going that direction, so we'll give it a shot.
Very cool. All right. Well, thank you so much, Scott.
Thanks for having me, Liz.
No problem. Have a good one. And now we are going to hear from Dan. Hey, Dan. How's it going?
Hi. So I'm Dan. I'm one of the CircuitPython core developers. And just a few hours ago, I released the final version of CircuitPython 9.10, which has been cooking for several months. And it's got a bunch of interesting new features and some less interesting new features, but I kind of summarized the things that I thought would be most interesting. So I made a slide for this.
Excellent.
Just go over it. Sorry for the presentation style.
No, it's all good.
And I put in the Discord chat, there's a link to the release notes. You can read in more detail about what's going on. So first of all, in terms of audio land, ESP32S3 now supports MP3s, which is great. And also recently, audio MP3 can now stream from HTTP servers. So you don't have to just decode an MP3 file that's on your device, but you can actually fetch something from the web and then stream it out, fetch MP3 from the web and then do that. And thanks to Jeff for doing that. And it's sort of still very early, but it's really neat.
Yeah, and Jeff just wrote a guide too to show folks how to.
Oh, great. Okay, I didn't know that. All right. maybe somebody can paste that in the the note in the stream also. In terms of Bluetooth, Scott finished completed the BLE implementation on Espressif, and I fixed some errors and some bugs with that, and now we have BLE GAT server support, so your ESP can act as a peripheral and present services, and it also does pairing and bonding. So this is pretty much makes it on parity with the Nordic NRF implementation and the Scilabs implementation, both of which also have Bluetooth. So
that's awesome.
It's really great now. So we have really, we have a wide choice of Bluetooth, and the ESP boards, which have a lot of memory and stuff like that, are really great for doing Bluetooth.
Yeah, I've been doing some testing with it, and there's some projects that folks have started working on the team, so we're going to see more of that. So it's really awesome. Thank you, and Scott, for working on it.
Excellent. Okay, thank you. All right. Then in terms of some more minor things, collections.dec, which comes from CPython, it's more like CPython now. We added some functionality. Keypad scanning, somebody contributed an implementation of doing keypad matrices where one side uses a multiplexer, which is true on some keyboards that where you don't have enough pins available on your microcontroller. Somebody else contributed a fancier debouncing scheme to keypad, and it's a little tunable, so you might try that if you're interested.
Cool.
It makes it a little more regular when you're trying to do stuff like maybe gaming or something like that. And finally, on Espressif, microcontroller that's CPU.frequency, somebody contributed it, so you now can vary the CPU frequency on Espressif. Can't really overclock them that much or anything, but you can like lower the clock to maybe reduce power and stuff like that.
Cool.
Pico DVI, which is kind of the HDMI DVI support on PyPico, supports some extra resolutions. And there's there's also a graphics module called _Eve, which you've had for many years, but it's now turned on many Espressif boards, anything with more than 4 megabytes of flash.
Cool.
In terms of networking stuff, you can use SSL on anything that provides something that looks like a socket, like Wi-Fi or Ethernet. And SSL socket now supports stream protocol. That's in terms of Python. It looks like a Python stream object. Deep Sleep is now supported on all Espressif chips. It used to only be supported on a few of them. And finally, on USB, we now have support for this external chip called the MAX3421E that's a USB host. That's in addition to the USB host support on the RP2040. And we also have a contribution from a user that allows you to rename USB MIDI interfaces and jacks when you're using creating USB MIDI devices, which a lot of people ask for. So you can have nicer looking names for your plugin, your USB MIDI projects. Nice. So take a look at this. It's available. Tell us about your bugs, whatever bugs you find, and we're continuing on some other stuff. But we're really this has really rounded out the CircuitPython 9, especially the BLE stuff, I would say.
Yeah, this is all really exciting stuff, and looking forward to digging into it. Thanks so much, Dan, for coming by and telling us about this.
All right, you're welcome. Hey, bye-bye.
Have a good night. All right, so now we're going to hear from some folks in the community. We're going to start with Boian. Hi, how are you?
Hello, everyone. I'm just working again on Visuino as usual. And let's see if I can share screen. If I can, if I can figure out again how to do it. Allow. So can you guys see the screen?
Yeah, we're seeing your screen.
Okay.
Great.
So fantastic. Move some things away. So I finished working on the MPRS sensor. I was working. Hope you guys can see it in the video. Let me move some more things around so I can see what I am actually showing. So this is the sensor, and let me show you how you can use this sensor in Visuino now. I did, by the way, both for SPI and I2C, and I mapped all the different versions of pressures. So you can select from the full list of sensors, both for the I2C and the SPI. And in this case, I have an Adafruit I2C version. I have decided to get the output in Pascals. Of course, Visuino has conversions. So now as we're talking, I built a project. So now we can, of course, here we have selected the right COM port. And now all I need to do is just click on this button to compile and upload the code. It's uploading. And any second now, we should be able to see the serial port. Okay, the serial port is coming. I can touch the sensor, and we can go to the scope, and you can see as I'm touching the sensor, we're reading it. So I did this sensor, took a couple of days. I did also the Wink Ethernet shield. I finished the work on this guy, which was sitting in the queue for quite a while, since last week. I did also not Adafruit product, but an important one. The Portenta C33 was added yesterday.
Very cool.
And yeah, I added a few other boards which will remain unnamed. But I am now slowly working on something even more important. This is the Vidor. I don't know if they are still manufacturing it, but what's important about this board, as many of you know, is that it has FPGA. Now, Visuino programs almost every single controller that's out there, right? But it programs only microcontrollers. So I want to move Visuino further and allow it to program both microcontrollers and FPGAs at the same time.
Oh,
so
very
you
cool.
can do your diagram and just push it, and it can program both the FPGA and the Visuino generating. Of course, it generates the Arduino code here, but it will also automatically generate the FPGA code, VHDL or Verilog. We'll see, or maybe we'll give both options. And then you can push it to your device. So that's a long-term project. It's going to take a long time, but I'm slowly chipping away at this guy. So that's what's been happening in the last week.
That's excellent. Thank you so much for showing us your progress, and I hope you keep coming back.
Absolutely. Thank you, guys.
No problem. Have a good night.
See you again.
All right, now we're going to hear from Christoph. Hey, how are you?
Hi, thanks for having me.
Of course, thanks for coming.
So I teach a course on designing scientific instruments, and as part of this, I teach PID control. And as you probably know, it gets quite mathematical quite quickly.
Yes.
So I've decided to build this setup here, which I call ping pong PID, which will sort of illustrate the entire process quite nicely, I hope. So there's a lot of Adafruit hardware here. You've got the displays, a rotary encoder, there's a distance sensor in here, and the key part is really this Perspex tube here. So we've got the distance sensor at the bottom. Then I took a fan out of a hairdryer, which is up here at the top. And in the tube, we've got the ping pong ball.
Very cool.
And using the magic of PID control, the aim is now that the microcontroller sets the voltage correctly so we can hover the ping pong ball at a defined distance, in this case, sort of 80 centimeters. And just to demonstrate it's working, so I sort of run this with the serial monitor in the Arduino IDE. So I'll tell you to start. And there we go.
Whoa.
It goes very nicely to 80 centimeters. And here the parameters are obviously optimized, right? So we can very easily change the set point, so we can go down to 30 centimeters if you want, for example.
Great.
It works really well.
That's so
Just
cool.
for illustration purposes, I can maybe give it sort of bad PID parameters. Then it would do something like this. Obviously, this is nice to illustrate to the students. This is how it should not be done. Just sort of finally, maybe a bit of an engineering nugget. That's sort of the piece where the ping pong ball rests in the beginning.
Oh, I see.
And I realized it's super important that you've got these openings here. So you get a smooth airflow around the ball, even if it does not take off. So if you don't have this, you wouldn't get a sort of a smooth lift off. Yeah. Yes,
That's
I hope
so
the students
cool.
will like it, and hopefully I can teach a bit better. Works with lots of different colors as well, of course, so the students can pick their favorite ones.
That's fantastic. Thank you for showing that. That was a really cool demo.
Welcome. Thank you. Cheers.
Thank you. Have a good night.
Same to you. Thank you.
Bye. Now we're going to have squid.jpeg play us out. Hey.
Hello. Hi.
How
Thanks
are
for
ya?
having me.
Of course.
So yeah, I wanted to show off a project I've been working on. I like to design and build kind of silly little escape room style video game style puzzle gadgets. The latest one I made is it's built out of a small little lunchbox. You can get these off of lunchbox.com. It's just simple, plain tin lunchbox.
Nice.
I built an enclosure inside and jammed a lot of electronics in it. I've got some space here for some cables. And a bunch of headphone jacks that I kind of use to make switchboard-style puzzles. Corresponding NeoPixel LEDs on each one, and a 7-segment display and an OLED for displaying various instructions or countdown timers. I've got a clear arcade button that I put a NeoPixel in as well. And then one of these really cool key and lock mechanisms that they've started selling on Adafruit recently to power it on. It's really neat. I've got the USB port so that you can charge the battery inside as well as program it with CircuitPython. And there's a speaker. And I've got another jack over here. This is for using more like a UART so that I can potentially plug in other devices in the future and communicate with it. And so just real quick, I'll kind of just show how I built it and then show a quick little demo of the game.
Cool.
But the thing itself is just a 3D printed box, basically, with a snap fit lid. And I put a bunch of magnets on the bottom with VHB tape so that it would stick to the lunchbox.
Oh, that's clever. Yeah.
Thank you. Thank you. It works really, really well. I was really surprised. And then inside, I just printed some 3D geometry to kind of act as spacers to hold it in place so it won't rattle around while you carry it and stuff. And see if I can open it up real quick. I can show off the guts. Let's see. So I used one of the, on the lid there, I printed some, what do you call it? Some little screw holes so that I can mount one of these cool swirly PCB mounts.
Oh, yeah, cool.
And I used a tripler, a feather wing tripler to build kind of like a little motherboard over there so I could plug everything in and rearrange things as needed, swap out parts if I needed to with the terminal, screw terminal blocks. It's using a Feather RP2040 prop maker. And a bunch of various other breakouts and stuff, and then you can kind of see in the back there. There's another little box with that contains the battery, so you can swap that out. And let's see if I can get this all back together now. I'll try and show a little demo of a quick little game I hacked together. Let's see. It can be a little tricky to get it back in there sometimes. There we go. All right, so I'm going to try and see if I can switch my screens here real quick.
Okay.
Let's see. Let's see. Okay, what I'm going to do instead, I can't figure out how to do that, so I'm going to switch my camera real quick.
Okay.
Let's see. Camera.
So while squid.jpeg is getting started, if anyone else wants to join too, we are going to have some time. And here we go. Hey.
Okay, so quick demo. Sorry, the quality of this camera isn't the greatest, and it's kind of dark, so
good.
you can see the lights. So it starts out by turning on. You plug in the key to turn it on. It'll go through a little computery intro animation here.
Nice.
And then when that's done, the game starts. And basically, there's only one thing to really do, and that's plug in. So we'll start by doing that. And as we do that, a countdown timer starts, and it informs me that I've got basically 10 tries remaining to figure out the connections. So you can see I've got a purple and a yellow connection lit up. So it's kind of a simple algorithm you can go through to get these in time without, too much trouble. The second time I got lucky and matched it right away. So I'll go down to the third one now. I got kind of lucky here again because these two match. So all I need to do is swap these two out. And I don't know if you can hear, but it plays little sound effects.
It's great sound effects.
Thanks. I believe I took these off of a freeware site. It's this guy Kenny who makes a lot of video game assets and things. So I borrowed those for a little bit, and I've got the last connection here with a few to spare and time to spare.
So cool.
Thank you. And so that's basically it. I tried to race that as quick as I could.
That's fantastic.
Thank you.
Do you have this written up? Oh, let me.
I don't have it written up, but I will have something written up. I kind of just, designed this and threw everything together really quick in the course of a week. And I'm surprised that it came together as well as it did,
It looks fantastic. I would have guessed it would have taken weeks. I would have never guessed a week.
I've attempted similar projects like this before, and this is the ones I tried before were maybe a little too ambitious. I have one with a larger lunchbox with a ton of hardware crammed in it, but it's I've had issues with it. Mainly, the microcontroller is not really powerful enough to do everything I wanted to do, and so I decided I would try and scale back the project to something slightly more purpose-based, and kind of one style of puzzle that I could play around with. And I can only fit so much stuff in this one since it's the small lunchbox, so I feel like that worked out really well in this case.
Yeah, that's amazing. Once you, if you write it up, feel free to share it in the chats, or we also have Adafruit Playground if you want to share it there.
I'll put it on my Playground page.
Yeah, fantastic.
Now that it's done, I think I can kind of go back over everything and write it all up.
Yeah, I know for me personally, with a project like that, when you then go back and document it, you almost get to kind of enjoy all the labor and hard work you went into it. So
kind of remember why I did things the way I did them.
Exactly.
Or ask myself why I did them in this crazy way.
That too. All right. Well, thanks so much for coming by.
Thank you.
All right. Have a good night.
You too.
All right. What a fantastic show and tell. Thanks everyone for coming by. Tonight there is no Ask an Engineer, but don't worry. Next week you will see JP's workshop at special time, Wednesdays at 8 p.m. So for tonight, stay cool if you are in one of the heat wave zones and keep making, and we'll see you next time. Have a good night.